Hey guys, so welcome back to yet another video. In this video, we'll be talking about generators and why they are used over normal functions sometimes. Okay, so now what are generators? Generators are just like iterators in Python that are a lot more memory efficient. Okay, so we talk about why they are more efficient. So first, let's take a look at a generator. Okay, now in a normal function you could use the return keyword like just once, right? But in a generator function you would use the yield keyword, and the thing is you can use it more than once. So if I define my generator function called gen, for example, I can be using the yield keyword. Okay, now in case I wanted to yield one sec, something like my name is John or something, let me just, okay, mm, let me just type this in real quick. Okay, now how do I get the output from this? Now I could just do like g equals gen. Okay, now let's see what happens when I print g out. Okay, let's see if I get the output I want. And there you go. It just gives me an object, a generator object. So how do I get this particular output? So now there are two ways of doing this. Like first I'll say the kind of the hard way. Now what you could do is you could do print, or no, what we could do is we could do answer is equal to next of g. So when you do next of g, it basically goes to the first yield statement. Okay, now when you print answer out, you should be getting the first word, that is my. Let's see, and there you go, we get my, right? Now if you just want to get all the words, what you would do is you would just copy this and paste this, and there you go, we get my name is John, right? So yeah, now this is like kind of a long way of doing it, and like it's not very efficient. Well, like you could do like this, but the other way of doing this is using a loop. Okay, so you could do for I in g print I. Now when you do this, you will be getting the content of all the yield statements together, and there you go, we get my name is John. Okay, now this is like the basic overview of generators. Like I will show you that like they occupy much less memory space. Okay, well, like they're not exactly faster, but they occupy much less memory space than actual functions. So okay, now I'll be making a normal function called num. Okay, now I will be making this function to multiply the multiples, or no, to basically add the multiples of 2. Okay, so now I will do while we could just put an n here as an argument, while n is less than or equal to 20, because I'll be like just doing this for 2. I could make a list actually and append it to that. Okay, so now inside the function I'll be making a list. Now I'll be adding the multiples to the list. Okay, so now I'll be doing n into 2. Okay, now that's basically it. Actually I will be a plus here. So now this will be giving me all the multiples of 2 and it will be adding them to the list. That's nums. Okay, now what I could do is I could just return nums here, which will be the list. Okay, now I'll be making my generator function. Okay, now in this similarly I'll be giving the argument as n. So while, so now in this there is no need of a list. I'll say y in a second. You can do while n is less than or equal to 20. All you need to do is just do yield n. Okay, you could do yield n, and after that you could just do n plus equals 2. Okay, now that is it. So I'll say why it is more efficient. Now if I print the sum of the first thing, that is sum of num of 2, okay, let's see what the answer is. Let's run this, and there you go, I get 110. Now let's print the same thing for the generator function and see if we get the same answer. Okay, sum of gen 2, and there you go, we get 110, right? So we get the exact same answer. Now, like, how do we know like which occupies less memory? So now we'll be importing something from sys. So from sys import get size of as s. Okay, now I could just check the size of the output of the num function and the gen function. Okay, now it will give me the output in bytes. Okay, and there you go, the space occupied by the num function is 92 bytes, whereas the space occupied by the gen function is 56 bytes. Okay, now like this may like not seem like a big difference, but when you're working with huge data, like the difference will be very big. So now let's say I want the multiple of 100,000. Okay, 100, 1 2 3 and one more, so basically 6 zeros. Let's do the same thing for this. Okay, now let's run it and see the difference, and there you go. Now you can see the difference that we got. We are getting such a huge number for the num function, whereas the gen function is occupying very little space. Now I'll show you the answer should be the exact same. Let's go back to sum and let's see if we get the same sum or not. There you go, we get the exact same sum. So that's why we use generators and why they are more memory efficient. Okay, now just like list comprehensions, you could also do certain generator expressions. Now the only difference is that generator expressions are done using a round bracket or a pair of parentheses, whereas list comprehensions are done using square brackets. Okay, now let me delete all this. I could do gen is equal to, now a generator expression will always be in a pair of brackets. Okay, let me just clear this out first. Now okay, I could do x for x in range. Let me do one, oh no, just till, let's say 15. Okay, or let's say 16. I want all the odd numbers up to 16. Okay, so I will do x for x in range 16 if x modulo 2 is not equal to 0. Okay, now let's print this out and let's see what we get. As you can see, it's a generator object. Okay, so we have to make a loop. So for I in gen, you could just print out I. Okay, now this should be giving you all the odd numbers, and there you go, we get 1 3 5 7 9 11 13 15. So they are the generator expressions. So yeah, that's basically it for this video. This was like a very basic tutorial for generators. Hopefully you guys understood the concept. If you have any doubts, do leave them in the comment section below. And that's it for this video, and I'll see you in the next one. Bye.